आज हम डिस्कस करेंगे अबाउट हाफ सबट्रैक्टर. In last lectures we discussed about half adders, then the full adder, then how we can design full adder using half adders. So in continuation of that series, means in continuation of designing arithmetic circuits, today we are going to discuss about the half subtractor. So as far as half subtractor is concerned, first point about is that it is a combinational logic circuit, like half adder and full adder. This half subtractor is also a combinational logic circuit because the output solely and solely depends upon the inputs that we are providing at that moment of time, and there is no role of any value stored already because we cannot store any value. There is no memory element in combinational circuits. So the next point is that the half subtractor performs the subtraction of two binary bits It means that the half subtractor uses the binary numbers, means either 0 or 1. Next point is that this half subtractor which has two inputs, so we can say that half subtractor has two inputs, and we name those two inputs as minuend and subtrahend. These are two inputs for the half subtractor. So for example, if a minus b we consider, so this a is known as a minuend and b is known as a subtrahend. So these are two inputs, and half subtractor has two outputs. Same, one is known as the difference of these two numbers. So one is difference, and if we need to have borrow, then the second output is borrow. So it has two inputs and two outputs. Next point is that we use half subtractor to subtract the least significant bit of the subtrahend from the least significant bit of the minuend. What does it mean actually? Say for example, we have two numbers a and b, and say for example a0, a1, a2, and suppose this is a 4-bit number, and suppose b is b0, b1, b2 and b3. So we are performing actually a minus b. So this is least significant bit of a, means minuend, and this b node is the least significant bit of subtrahend. So we use half subtract to subtract the least significant bit of this subtrahend b from the least significant bit of minuend. So this is the main points of half subtractor. So we can say that this is the first point that must kept in mind. And the second point is its block diagram. So as far as block diagram is concerned, say for example, this is one block. We name this block as a half subtractor. So this is a half subtractor. Okay. So this is half subtractor, and it has two inputs, A and B, and A is known as a minuend and B is known as a subtrahend. So these are two inputs. Same way the resultant is also two. One is a difference and the second one is a borrow. So these two are the resultant bits. This is output and this is the input, and these are two resultant bits. Resultant bits. Now the third point is it's what we say, it's a truth table. Truth table. So third point is it's a truth table. So the truth table is we take two inputs A and B, and same way two outputs, so difference and borrow. If there are two inputs, then there can be four combinations 0 0 0 1 1 0 and 1 1. So when there is A is 0, B is 0, so difference is 0, no borrow is required. But when A is 0 and B is 1, means B is greater, A is lesser, so we need to take one borrow, and if we take one borrow, so we need 1, and it becomes 1 0, so the difference is 1. So whenever this B means a subtrahend, is greater than the minuend, we always require to take one borrow. So borrow is 1, it becomes 1 0, so the difference is 1. 1 0, difference is 1, no borrow is required. 1 minus 1 0, and no borrow is required. So this is the truth table. Now we will have the K-map and its circuit diagram. So the next point is K-map for getting the Boolean expressions. So when these values are entered with the help of the truth table that we discussed at third number point. Now when A is equal to 0, B is equal to 0, means the difference is 0. This is for difference, this is for borrow, and borrow is also 0. When 0 1, 0 minus 1, it means the difference is also 1, and we need to take one borrow also. 1 minus 0, 1 is the difference and no borrow is required. 1 minus 1, 0, and obviously no borrow is required. So these are two groups. So we get here the expression for difference is equal to A bar B plus AB bar, like the half adder. So we know that in half adder also we got for some part as A bar plus exclusive or B, and for borrow only this much. So for borrow we require the Boolean expression is A bar B, A bar B. So this is the Boolean expression for a half subtractor. And now the last point is its circuit diagram. So circuit diagram is, so this is the circuit diagram. For difference we have A exclusive or B. These two are inputs. So this is exclusive OR gate. So the difference is A exclusive or B. And for borrow is A bar B. So this is A bar and this is B. So the borrow is A bar B. So because this is one AND gate. So this is the circuit diagram. We can also check the circuit diagram. Say for example when A is also equal to 1 and B is also equal to 1. So this becomes 1 exclusive or 1. So this is, we all know that this is 0. Okay. And this is 1 and A bar, this becomes 1 actually. And A bar is 1, so complement is 0. So 1.0 is equal to 0. So the borrow is 0. So see, when A is equal to 1, B is equal to 1, the difference is 0. The difference is 0. And when A is equal to 1 and B is equal to 1, then the borrow is 0. Then the borrow is 0. So this is the circuit diagram. And we also checked our circuit. And the next is some of the uses of half subtractor. So these are some of the uses of half subtractor. First of all, it is used in arithmetic logic unit to do the arithmetic calculation. We know that arithmetic logic unit is a part of CPU. Now it is used to subtract the least significant column that we already discussed. It is used to subtract the least significant bit of the binary numbers. It is used in amplifiers, means because when there is a transmission of a signal from one point to another point, there is the distortion of the signal because of the noise. So because that noise is inevitable, it is certain to happen. So it is also used for the amplifications of the signals. So this is the sixth point is about its uses. And like the half adder, this half subtractor is also have one limitation. So this is the last point, is the seventh point, is its limitations. So what is its limitation? That half subtractor does not consider, means takes into account the borrow in if there is any borrow in from the previous stage. So from the previous stage. So this is the limitation, that it does not consider the borrow if there is one from the previous stage. So this for resolving these limitations, we actually make use of a full subtractor that we will discuss in coming lectures, so that limitations can be resolved. This problem can be resolved using the full subtractor. So this is a very brief introduction and the circuit diagram of the half subtractor. In the next lecture we will discuss about how we can design the half subtractor using universal gates. Thank you for watching.